This particular figure is showing another possible cause of Down syndrome, which is familial Down syndrome. The normal, I guess you'd say, or typical Down syndrome is caused by non-disjunction. In this particular case, it's not non-disjunction, but it's a chromosomal abnormality or mutation called a translocation, which is where one portion of a chromosome breaks off and fuses with a portion of another chromosome, creating a translocation. And this translocation can cause, if there's sufficient chromosomal material, can cause similar results in appearance to a trisomy. And so I'd like to go through this figure with you because it is a little bit complicated. I apologize, the scan version, it's not completely clear because the figure is so small in the text. So you've got this in front of you. Let's look at it together. So we start with our normal parent. We're looking at two chromosomes here. It's chromosome 21 and chromosome 14. So remember, during the process, and by the way, they're showing non-duplicated chromosomes now. I realize that can be confusing because sometimes they're showing duplicated, sometimes they're showing unduplicated chromosomes. So you have the homologous pair, one from mom, one from dad, one from mom, one from dad. So two homologous pairs of chromosomes will undergo gametogenesis. Remember, homologous chromosomes would separate meiosis 1, sister chromatids would separate meiosis 2. What you're ending up with is the gamete, in this case, is being shown as we would have one copy of 21, one copy of 14. So that's the gamete, and that's the traditional or typical or normal case. Now let's look at a situation where we have a translocation. In this case, it's called a translocation carrier because the person has one normal 21, one normal 14, and instead of having individual chromosomes, has the translocation fusion of 1421. So in other words, they have a significant portion of chromosome 14, a significant portion of chromosome 21. They're simply fused together. So what are the possible outcomes in gametogenesis? Well, we could have the situation where the 21 and the 14 go together to produce one gamete, and the translocation chromosome is in the other gamete. A second possibility would be that we would have the translocation and the copy of 21 together in the same chromosome. So now you can see we have a situation of too much chromosome 21 in this case, and then we have the 14 alone by itself. In other words, no chromosome 21 with it. And then the last possibility, we would have the opposite situation, which is the translocation, this time with chromosome 14 and 21 being by itself. So now what we're representing in this lower portion is the zygote, which is again the fertilized egg, which is a result of the fusion of the gamete from the normal parent with a gamete from the translocation carrier. And so the first possibility that can happen in the fertilized eggs is we produce basically what we started with, which is another translocation carrier. The second possibility that could happen is if we had this particular egg being fertilized, for example, by this particular sperm, is we would end up with in terms of karyotype, a normal individual in the sense that there was no translocation chromosome present. So probability wise, this would represent about 2/3 of the live births, and the key there is live births because the individuals who end up being monosomic for 21, trisomic for 14, or monosomic for 14, in those particular cases, that's being represented as a lethal outcome. In other words, this individual would not develop to term. There would be spontaneous abortion as a result of those chromosomal abnormalities. The situation that results in the familial Down syndrome is shown here, which is we have the gamete that has two copies of 21 along with one copy of 14. And so what we end up with is a situation where we have the two 14s. However, in this case, we have the two 21s and then a portion on the translocation chromosome, which gives us the third 21. So this is how familial Down syndrome is passed from generation. So it's not a non-disjunction phenomenon, it's a translocation phenomenon that results in this outcome.